Hi, this is Mr. Nazarian. Our lesson objective today: I can double and half volumes of rectangular prisms and find the new dimensions. 5th grade standard measurements and data, C5C. We have here a rectangular prism, as you can see, and it's already labeled with the dimensions. Go ahead and find the volume of this rectangular prism. Alright, well, I know that it's going to have a length of 15, a width of 4, and a height of 4 feet. So I'm just going to use the formula for finding rectangular volume of a rectangular prism, multiplying 4 times 15, which gives me 60, and 60 times 4 gives me a total volume of 240 cubic feet. But let's say that I want to double this volume. So I want to have twice as much volume for whatever this is. For some sort of space, I want to have twice as much. It's not enough space for me. So if I was to double it, that means I would add another volume, another total volume of 240 cubic feet. I still want to keep it as a rectangular prism. So I'm going to go ahead and this is the exact same shape here, right? It's the exact same amount of volume. I'm just going to stack it right here. What is the new dimensions of, this is all just one piece now. Now it's a total of 480 cubic feet for this total amount here. So what are the new dimensions of this rectangular prism? Go ahead and state the 3 dimensions of this new rectangular prism with a volume of 400 cubic feet. Okay, so if we take a look at this, we can see that this, the way that I've stacked them, the length has not changed at all. It's still 15 feet. We can see that the width here is still 4 feet. But what has changed is the height. The height now is 4 feet from here to here and another 4 feet. It's like adding a whole other layer, another story to a building. So of the 3 dimensions, only one of the dimensions changes. So now we've got 8 feet for the height. Notice that of the 3 dimensions, only one dimension changes. In order to double this volume, only one of the dimensions doubles as well, right? So to double the volume of a rectangular prism, we only need to double one dimension. Not 2, not 3, just 1. What if we had the volume of this right here? We have this one, and don't really pay any attention to this line here. We got some glued together. It's one piece. We got one rectangular prism. And for the total dimensions of this big rectangular prism here, we have a length of 10 feet, a width of 2 feet, and a height of 8 feet. So what would the volume of this rectangular prism be? All right, it would be 8 times 2, which is 16, times 10 would be 160. So it would be 160 cubic feet for this whole thing. But you know what? I don't have enough room for something that's 160 cubic feet. I only have half of the space for that. So I need something that's only going to have a total volume of 80 cubic feet. So I need to half this volume. Can you guess what we need to do to the dimensions of this rectangular prism to half the volume? What should we do with these dimensions? Go ahead and list one of the possibilities for what the new dimensions of this rectangular prism would be where I could have half of the volume. Okay, so here's the thing, is even back here, when I remember I doubled the volume of this rectangular prism from 240 to 480, and I doubled one of the dimensions, right? It doesn't have to be height. It could have been anything. I could have, if I put them, if I put this side by side here, and I didn't do a really great job of making this, but then it wouldn't have gotten any taller, right? and it wouldn't have gotten any wider, but it would have gotten twice as long, right? Just one of the dimensions changed. It doesn't matter really which of the dimensions changes. It's just that one of the dimensions is going to double in the case of when we're doubling the volume. So what would the new dimensions, what is one possibility of one of the new dimensions? Well, one, if we're going to half the volume here, is we're going to half one of those dimensions. So for me, just because it's easiest for me, I'm going to half the height. So it's still going to be 10 feet long. It's still going to be 2 feet wide, but now it's only going to be half of 8 feet, which is 4 feet tall. Okay? So now, and we can check this to see if this is right. 4 times 2 is 8. 8 times 10 is 80. And 80 is half of 160. So again, if we want to find half the volume of a rectangular prism, we only need to half one of the dimensions. Again, it doesn't matter which dimension we half, we just have to half one of the dimensions. If I had kept the height at 8, but I halved the length, and this is going to look weird, but just these numbers wise, if we did 5 times 2, that'd be 10. 10 times 8 would be 80. If I kept the length 8, kept the height, the length 10, kept the height at 8, but I did half of the width, that'd be 10. 8 times 1 would be 8. 8 times 10 would be 80. So as you can see, it doesn't matter which dimension we change, as long as it's one dimension that we change when we're either doubling or halving the volume of a rectangular prism. Okay, I'm going to work more on that tomorrow. See you then. Bye.